Okay, today's agenda. So we are going to discuss about some theoretical concepts associated with subnetting, supernetting, IP addressing schemes, and port address. Okay, that's a discussion for today's agenda. So here, first let me start the discussion on some theoretical concepts on IP addressing and subnetting. Okay, followed with let me start our discussion on RDS, relational data store, under which how to connect to a MySQL instance. Okay, this is the agenda for today's session. Sir, do you aware of? I need a answer from all of you. You people, do you aware of the concept of subnetting? Subnetting, how to split a subnet, how to find the range of IP addresses within subnet. Okay, yeah, yes. I got an answer from someone, sir. Sadiq, I think so. Yes, yes, Sadiq. Okay.
I know what is subnet.
Subnetting.
Yeah, I know that.
Okay. So, how many subnets that we can split for this CADR notation? Sadiq, how many computers that we can have in this subnet? Given
It's
this IP address and the CADR mask, how many computers that we can have here?
for that need to use a subnet calculator to
Little
see
bit
how many
louder, I
calculator
couldn't
for.
able to hear. Please wait a while.
Better we can use a subnet calculator to get a correct answer correctly with the class A IP address.
No, so that is the reason why we need to go with. Okay, once you look into that, there is no need of a calculator here. At the maximum, we
Okay.
can have 2 to the power of 4. Okay, how to compute all those things? Everything will be discussed. So because our
Okay.
discussion on this VPC, virtual private cloud, and our discussion on how to integrate a web server with the backend database server. In this case, the database server will be loaded with private subnet, and the web server, sorry, will be launched in a public subnet. So what are all the IP addresses that we can assign for this subnet, range of IP address, everything that we need to know for all our further discussions. Okay, whether we have completed IAM.
Yes, we have completed IAM, but we didn't do any auto scaling rest of the part.
Auto scaling, we have to do auto scaling, no issue. Okay, so here we are
Okay.
for the first level, we are going through the basics. After that, we will club all the things. What is
Okay.
real time? Okay, so here first let me start with this IP addressing scheme. So here, what are all the addresses that you need to access a computer in the internet? You are having a computer, so this is your source network. This one corresponds to your destination network. You want to transfer data among between this computer. Intermediately, we have several networks. Yes. So what are all the addressing schemes that we need in order to make these two computers that need to communicate? First one, you need to know about this MAC address. Being you are with the networking, you know what is MAC address. This MAC address is otherwise called as Ethernet address, or it is called as a physical address. All the names are same. Okay. The second type of address is logical address, or we otherwise called as network address. And third type of address is port address. So all the three addresses are needed in order to identify a computer in a LAN or a WAN, whatever may be. Okay. So what is MAC address? So within a local area network, any computer can be identified by the protocol, whether it is a TCP or any other protocol, only by its MAC address. Okay. So we are using IP address for your convenience. Okay. Another question. So if I use an IP address 192.100.10.1, if I want to convert this map this IP address into corresponding MAC address, which protocol will facilitate this mapping? Anyone? Usually, this IP address that we assign to our computer is for our simplicity. So, for the user simplicity, for user understanding. But in reality, a computer will be exchange information based upon this MAC address only. All the underlying protocols will follow this MAC. So, if we give a IP, it need to be converted into a corresponding MAC. Who will responsible for converting this thing?
MAC table.
MAC table will contain the information. Okay, MAC table will contain the information. Initially, the MAC table will be empty. When you switch on this circuit, when you switch on the network for the first, whether anything is populated in the MAC table, no, it will empty. The MAC table will learn by itself. Whenever the traffic starts flowing across computer, based upon that, the MAC table will learn by itself. Which protocol will assist the MAC table to learn in this perspective? You have heard about a protocol called as ARP, Address Resolution Protocol. Okay, so these are all some of the interview questions that we may face when you go up with this VPC, Virtual Private Cloud. In a real time, it will be applicable. Almost each and every organization will have their own VPC, and we need to aware of those concepts. Okay, ARP protocols responsibility. ARP stands for Address Resolution Protocol. This protocol operates on the data link layer. In terms of this OSI model, we have a 7-layer architecture for networking. This protocol operates on data link layer. Okay, so there is another protocol RARP, that is Reverse Address Resolution Protocol. Okay, it does the opposite thing. Given a MAC address, to find the corresponding IP address, RAP will assist. So when you first switch on your network, your local area network, the MAC table is empty. So during each and every transactions among these systems, the MAC table will learn by itself and it will populate the entry. What is the port number? What is the corresponding IP address? And what is the corresponding MAC address? Okay. So which port number the machine with following IP address and the associated MAC address is corrected will be learned step by step. Okay. So during this process, if you give a IP address, the address resolution protocol, what it will do, it will help the MAC table to build the entry. Okay, so this is the way by which system in a local area network can be identified given IP address by the administrator. So that is the first address. The MAC address, the size of the MAC address is 48 bits. So it will be in a hexadecimal format. You all people are aware how a MAC address will looks like. Okay. Our discussion is going to be focusing on the logical address and port address. So not on MAC address. So here this 48 bit divided into group of 8 bits called as octets, and we will be having 6 octets. Okay. The octets has been represented in a hexadecimal notation. This is the concept associated with this MAC address. So here, the second type of address, okay, a computer within a local area network can be identified with the MAC address. If it is internet, there are multiple networks. How a network can be identified? A network can be identified using a logical address, otherwise called as network address. For this purpose only, we are going to make use of this IP addressing concept. Okay. So in terms of IP addressing, there are two types of addresses. You people already aware. One is a classful addressing scheme. Second one is classless addressing scheme. So for you to make an understanding of subnetting, you need to go for an in-depth discussion on this classful addressing scheme. The IP, we are talking about IP version 4, whose address size is 32 bit. Okay, we can have at the approximate 420 crores of unique addresses if it is IP version 4. Okay, here the addressing scheme which is coming under IP version 4 will be either a classful addressing scheme or it will be a classless addressing scheme. We call this classless scheme as a CADR, classless internet domain routing. Okay, so here in classful scheme, initially at the time of invention of this internet working around 1970s around, okay, so they divided the IP address into 5 classes, okay, based upon the utilization, based upon organization need, the IP addresses, that's version 4. Totally we have 420 crores of addresses which has been split into 5 classes. We have class A, class B, class C, class D, and class E addresses. Okay, so classful scheme can be identified whether the address belongs to classful scheme or not can be identified by looking into this first octet sphere IP addressing scheme. So here in each and every scheme, if you take IP address, you can have the IP address will have the following thing. It will have a network component. It will have a, if your network is divided into subnet, it will have a subnetwork component and it will have a host component. Okay, all the 3 can be represented within an IP. Example 192.100.10.1. We have a network part, we have subnetwork part, we have host part. Okay, within that. So here in this case, how many networks that you can have for a class A, how many hosts that you can have for a particular network under class A, class B, class C, then what is the difficulty associated with the classful scheme and why we are following classless scheme. These are all the things that we are going to discuss now. So here if it is a class A, now let me forget for a while the subnetting concept. Let me focus on the networking and the first part of this IP address. So for a classful addressing scheme, here the first octet, as I told, this IP version 4 contains a group of 8 bits called as octets, and we have 4 such octets. The classful addressing scheme contains the first part dedicated to network and the remaining 3 parts dedicated to host. Then in class B addressing scheme, the first 2 parts is dedicated to network, which is for network, and this corresponds to host. And in class C IP addressing scheme, first 3 octet is dedicated for network and the last one is for host. And for class D, which is a multicast group, all the 4 components will be dedicated for network. It is reserved for scientific purpose. Now you give me the answer. How many computers that we can have for a class B network? If this classful scheme, how many computers that we can have for a class C network? Anyone? If you know, please. Sadiq, you can give the answer. How many computers that we can have in this scheme at the maximum given IP address? If it is a class C, how many computers that we can have on that particular class C network?
Belongs to subnet value. For example, if you define a subnet value with the 24 in class C, we can have only 254 IP addresses.
Okay, so in this case, we have only 254 IP addresses. Very good, good answer. Okay, so here if we have one subnet, if we have n number of subnet, accordingly it will be split. We are going to discuss about how to split according to our number of subnets requirement and what are the range of IP addresses that we can have within that subnet. Okay, so here in terms of class A network has been concerned. Here, how many bits are there? It is 8 bit. Each and every octet is an 8-bit octet. So how you can identify address belongs to class A or class B? Here, in the first octet, if the first octet, so if the value starts from 0 to 127, it will be class A. In this case, 0 and 127 is reserved for a special purpose. 0 represents this internet address. You can't make use of this address. So in our cloud, from anywhere in our security group, if we want to connect to the computer that we are launching in Amazon from anywhere, which address that we are representing 0.0.0.0/0. This is the internet address. Then 127 is the loopback address. If you want to make a check whether a computer is properly connected to the network, this is the loopback address. Okay. So 0 to 127 is the classful addressing scheme. All the addresses excluding 0 and 127 starting from 1 to 126 will be coming under the classful scheme. So in class B, starting from 128 up to 191 comes under class B. So 192 and up to 223 comes under class C. 224 to 239 comes under class D. 242, 255 comes under class C. Okay. So these are all the first part based upon we can able to identify to which address it belongs to. Okay. So this is the representation in forms of the decimal notation. If we go for identifying using a binary, this is the first bit starts with 0. Here the first 2 bits start with 1 and 0. Here the first 3 bits starts with 110. Here 1110. Here 1111. So this is the way by which address can be identified. Okay. So if it is a class A network, how many total networks is possible is the first bit is reserved for to identifying this network address. Remaining we have 7 bits here. We have 8 plus 8 plus 8. We have 24 bits here. Therefore, we have 2 to the power of 7 networks and 2 to the power of 24 minus 2 hosts in that network. Okay, that is the logic associated with in finding out how many networks and how many hosts within that network. If it is a class B, okay, so here you leave the first 2 bits, which is remaining. We have 6 bits in the first octets and remaining 8 bits in the second octets. Therefore, 2 to the power of 14 networks, and for remaining 2, 8, we have 2 to 88 bits. We have 2 to the power of 16 hosts within that. Each and every network is having 2 to the power of 16 hosts. Okay, totally we have 2 to the power of 14 networks. If it is class B, and if it is class G, you leave the first 3 bits. We have left out with 5, 8 plus 8. We have 2 to the power of 21 class C networks and 2 to the power of 8. Okay, 16 minus 2, 8 minus 2. That is what Sadiq represented. 254 hosts in this network. Okay, so here this is the way by which we need to compute how, if it is a classful scheme, how many networks belonging to the particular class, and within each and every network how many hosts that we can have. Okay, this is the formula associated with that. Now we are not making use of this classful scheme. Why so? Because of some poor allocation policy. For example, if you take class A network, we have only 126 class A networks throughout the world. Okay, class A network, we have only 126 class A networks throughout the world. Each and every network we can have at the maximum of 2 to the power of 24 minus 2 computer. That is equivalent to 1 crore 67 lakhs 77,214. This is the exact number of computers that we can have in a class A network. So imagine if you can have this much of computer under a particular company, it is not at all possible. If you take a company like even Microsoft, imagine Microsoft is having offices across 500 locations throughout the world. Let me imagine. Okay, at each location they are having around assume 5,000 computers. How many computers that they can have? At the maximum 25,000. 250,000 computers alone can have across 500 locations throughout the world, and each and every location is hosted with 5,000 computers. The office of Microsoft Here we have only 250,000 computers. Assume the class A address if it is assigned to Microsoft. So here at the time of initial level of internet in 1970s, the Internet Assigned Number Authority, what it did, it assigned a class A IP addressing for the government sector companies and big corporates associated with United States of America, USA alone. Okay, very big corporates associated with US and government sector alone will be given a class A address. And the class B address has been given to some mid-level companies. Okay, so it's because so if a company want to host more than 254 computers in this case, they want to get a class B address. Company with thousands of computers can be utilized with this class B. How many computers that we can have in a class B? If it is a class B, then maximum number of computers that we can have is 55,534. That is the maximum number of computers that we can have in a class B. In class C, 254 is the maximum number of computers that you can have in a class C. Okay. Now, so now we are in the discussion of example with the Microsoft. So imagine Microsoft itself will be having only 250,000 of computers. But if Microsoft is assigned a class A, how many computers that it can accommodate? The class A address can accommodate up to 1,67,000. Imagine Microsoft assigned a class A address. So after assigning addresses to 2.5 lakh, remaining almost 1 crore and 60 lakhs of computer is going to be lying vacant. Okay, IP address is unused. By the way of this poor allocation policy, so out of this 420 crores of addresses, which is spreading across class A, class B, and class C category, almost 300 crores of addresses assigned to class A and class B has been wasted. We have left out with only 120 crores of addresses. And during this growth of internet in after 2000, 1995 to 2000, if the number of addresses, if we follow this classful addressing scheme, so it is not possible in future to accommodate all the devices when it need a connection with internet. Also because at the time of 1995 and 2000, they have left out with only around 120 crores of IP addresses. Okay, around 120 crores of IP addresses in this classful scheme. Now they took a decision going for a classless IP addressing scheme. In this classless IP addressing schemes, okay, they will assign the IP addresses according to the user's requirement in terms of multiples of 2 to the power of n. For example, if a user is looking for a computer network with 5 computers, then you need to get 2 to the power of 3. 2 power 3 is equal to 2 2s are 4, 4 2s are 8. Okay. Then 8 IP addresses can be assigned. So starting from address 1 to 8. So after assigning 5 addresses to 5 computers, only 3 will be wasted. Okay. Yeah. So in this case, if the user is assigned, he needs a 5 computer. If it is a classful scheme, you need to be assigned with a class C IP address. You can have at the maximum 254 computers. After assigning IP to 5 computers, the remaining we left out with only 249 IP addresses. Okay, so it will be wasted. So by the way of assigning a classless IP addressing scheme, we can able to reduce the number of underutilized IP addresses. That's the advantage here. If a user is looking for 30 computers in his network, okay, what you need to do? You want to get an IP address 2 to the power of 5. At the maximum, we can have 32 IP address. Then minus 30, only 2 addresses will be wasted. So this is the concept behind this IP addressing scheme. Okay, so before going into this concept of subnetting, you need to know about this mask. There are 2 types of mask with respect to this IP scheme has been concerned. One is a default mask. The second one is subnet mask. We have default mask and we have subnet mask. So the default mask will be assigned to classful scheme. We have class A, class B, and class C. Here for a class A, the default mask is 255.0.0.0. For a class B, the default mask is 255.255.0.0. For class C, 255.255.255.0. Here, if we are representing in a notation, CADR notation, here it is 256 can be represented as 8. Here the number of 1 bits. Okay, if it is 255 instance, all the bits are 1. Remaining all are 0. Okay, that is the meaning. Remaining all the bytes are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7, 8. Okay. So this is your first octet. The first octet, if it is all ones, it is remaining 0, 0, 0. Therefore, total number of ones here is 8. That is represented here. Here the total number of ones are 16. Here the total number of ones are 24. So this is the way by which you can need to assign a mask here. Okay, that is a default mask which is fixed. What's the need of going for this default mask? Given an IP address to identify which is the network part, which is the host part, we need to go for this masking concept. Okay, so given an IP address, let me make it 192.100.10.5, which is the network part. First, what you need to do, you want to first look into the IP address and you need to identify to which class it belongs to. So, to which class this IP address belongs to. In this case, this IP 192 belongs to a class C, you people are aware of. Therefore, you want to take this class C mask and you want to apply this mask here. Okay, so we want to apply 255.255.255.0 and you want to perform exclusive OR operation. You want to perform exclusive OR operation. In this sense, you will be having, if you have a 255, then exclusive OR with 192 will result in 192 itself. Okay, so here you want to make a conversion into binary bit, and if 0 0 and if it is 1 and 1 and 0 1 and 1 and 0, these are all the 4 options. Okay, if it is here 1 and 1, 1 will be 1, all other remaining thing are 0. So by the way, if you apply 255 on top of 192, you will be getting the same thing, 192.100.10, and if it is 0, then it is 0. Here, if a mask, default mask is applied to the network address, we can able to get this network component. So in this case, the first 3 part is the network component, and the last part is the host component. Okay, this is the way by which by applying a default mask, we can able to identify what is the network part and what is the host part. If you have any doubt, please let me know. You can take another address. 150.100.75.50. So to which address it belongs to? It belongs to class B address. Therefore, the mask is 255.255.0.0. If we perform an exclusive OR, the network part is 150.0.0.0. The host part is 75.50. Okay. Here it will have a. This is the way by which you can able to identify what is the network address and what is the host address. Okay, so for all the IP schemes, this is the way by which you can apply. Then where comes this subnet mask? What is a subnet? So if your network is divided into various smaller networks, okay, then it is called as a subnet. If you divide the subnet, you need to assign a subnet mask. If you divide a network into smaller networks, in this case, you need to go for this subnet mask. Okay, so let me discuss this subnet. Sure. Imagine, let me first start with this classical IP addressing scheme. What are all the things that we need to aware if you go for this subnet is, you need to find out the subnetwork address. Before that, you need to find out the subnetwork mask. And once the subnetwork mask has been found out, you can find the subnetwork address, and third you want to find out the range of IP address that you can assign in the subnet. Okay, these are all the three things that is mandatory for our discussion, security perspective, for our discussion on the virtual private cloud. Okay, so in almost all scenario, you will be having your computer in a company. If your company is having a computer in Amazon cloud, they will create their own VPC. Under VPC, they will create multiple subnets, and they make a subnet as a private or a public according to the requirement, and they will have the store their system. They have the system according to whether it is open to public or whether it need to be hidden. Based upon that, it will be loaded whether in a public or private subnet. So this subnet concept is very must. Okay, so let me first start with this subnetworking address mask. How to find out the subnet address mask? Okay, so here let me take a small problem. So given the IP address 192.100.10.0, this is the network part. Okay, what we want? We want to divide this a company XYZ is assigned the IP address, a class C IP address. The company has having 5 branches. Under each and every branches, we need to have maximum of 30 computers. This is the scenario given. First, we want to find out the subnetwork address, subnet mask. The second step, you want to find out the subnetwork address. Then third step, you want to find out the range of IP address within the subnet. Okay, these are all the 3 things that we need to go for. First, how to find out a subnet mask? We have a formula here. Okay, first what you need to do, given an IP address, you want to identify the class 255. The default mask for this class C is 255.255.0. This is the default mask. What you need to do, you want to apply this default mask into this network address. Okay, so here you want to make it this default mask. The first 3 belongs to network and the last one belongs to host. Okay, if you want to divide this network into smaller networks, what you need to do, you want to borrow some bits. Okay, you have host bits 4 zeros, 8 zeros. You want to borrow some bits from the host. Okay, and you want to make a mapping by if you borrow 1 bit, how many number of computers that can be accommodated. Similarly, you want to take a second bit, third bit according to your number of computers in that subnet. Here the requirement is 5 branches at the maximum 30 computers per branch. This is the requirement. Therefore, you take first, you take this 0 and make it 1. 2 to the power of 1. We can have at the maximum only 2 computers. That is not possible. You borrow additional 1 to 1. 2 to the power of 2, which is equivalent to 4. That is not possible. What is your requirement? You need to have 30 computers. Therefore, you borrow the third bit. That is not possible. Borrow the fourth bit. So 2 to the power of 4. 2 into 2, 4. 4 into 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. That is not possible. 2 power 5. It is equivalent to 32. Okay. Now, you need to get 5 bits from the host to divide this network into 5 subnetwork. Okay. So therefore, so each and every subnet, how many subnet that you need to have? Okay. So in this case, it is a subnet. Now, in the, how many subnet that we need to have? So here the number of subnet that we need to have is 5. Therefore, we no need to we need to have 5 subnets. Therefore, okay, 2, 3, 4, 8. If you get 1 bit, if you borrow 1 bit, 2 to the power of 1. Okay, if you borrow second bit, 2 to the power of 2, which is equal to 4. So 2 to the power of 3. Okay, 2 to the power of 3, which is equal to 8. Therefore, we need to borrow 3 bits. Okay, so why so? Because we need 5 subnets. Then if we borrow 2 bits and we can have at the maximum only 4 subnets, that is not sufficient. Therefore, we need to borrow additional bit 2 to the power of 3 instance. At the maximum, we can have 8 subnets. Our requirement is 5 subnets. Okay, so how many bits that you have left out for this host? These are all network part. This corresponds to host part. So after giving 3 bits for subnetworking, we have left out with only 5 bits. Okay, therefore 2 to the power of 5, which is equivalent to 32 computers. 2 power 5, 32 computers that we can have on a particular subnet. So it 7:55 தான் ஆகுது. நான் வரேன். 7:55 தான் ஆகுது. கிளம்புங்க. We can have at the maximum, here the mask is 255.255.255 and 111.0000050. So this is the binary value. You want to convert it into, this is a into decimal form. Okay, how to convert this binary into decimal form? So you have 111.0000050 into 2 power 0 into 2 power 1 into 2 power 2. Similarly, 2 power 0, 2 power 2 power 2, 2 power 3, 2 power 4. You have 2 power 5, 2 power 6 and 2 power 7. Now you have values for 2 power 5, which is equivalent to 32, 2 power 6, which is equivalent to 64, 2 power 7, which is equivalent to 128. Therefore, if you sum all the value, 8 plus 2, 10, 14. Here 6 plus 3, 10.